Have you ever just looked at a piece of software and wondered, how does it seem to think? How does it decide what to do from one second to the next? Well, that's not magic. It's logic. And today, we're going to pull back the curtain and look at the instructions that let us teach our code how to make decisions. So let's start with that big question. When you click a button or type a word, how in the world does the program know which path to take out of all the possibilities? It's not just guessing. There's a carefully designed roadmap it's following. And the answer to that question is a concept called control flow. Honestly, the best way to think about it is like the program's own internal GPS. It's constantly looking at the map, which is our code, and deciding every single turn, every stop, and every action it needs to take along the way. All right, so where do we begin? Let's start with the most basic, most fundamental decision a program can make, a simple fork in the road. And for that, we use the if-else statement. The easiest way to wrap your head around this is with something you do every single day, pulling up to a traffic light. Your decision is totally binary. It's one of two things. You either stop or you go. And here's where it just clicks. Look how perfectly our real-world logic translates directly into code. The thought process in your head, okay, if the light is red, I stop. If it's anything else, I go, is written almost exactly the same way in Java. If a certain condition is true, the first block of code runs. If it's not, the else block runs instead. This simple structure, believe it or not, is the foundation for pretty much all complex decision-making in programming. Okay, simple two-way choices are great, but let's be real. Life is usually way more complicated than just stop or go. What happens when you've got a whole menu of different options to choose from? So just imagine you're at a restaurant looking at the menu. You don't just have two choices, right? You've got a whole list of items. Your brain needs some way to process that list and then pick one specific action based on the one thing you choose. This is exactly where the switch statement comes into play. It's perfect for this. The program takes your choice, let's say you tell it pizza, and it scans this list of possible cases. As soon as it finds a match, boom, it executes the code for that one specific choice. It's a super clean and efficient way to handle a bunch of different options that all depend on the value of just one variable. So this means you should probably reach for a switch statement anytime you're checking one variable against a list of specific, different possibilities. It keeps your code so much cleaner and easier to read than a giant, messy chain of if, else if statements. All right, we've totally covered making one-time decisions. But what about doing things over and over and over again? Well, for that, we need one of the most powerful tools in all of programming, loops. So, first up is the for loop. This is your go-to, your workhorse, when you know the exact number of times you need to repeat something right from the start. You know where you're starting, you know where you're ending, and you know exactly how to count from one to the other. Let's make this really tangible. Imagine I tell you to take exactly 10 steps. Your brain automatically follows a little routine, right? You start your count, you take a step, you check if you're done, and if not, you repeat. That little 4-step process running in your head, that is precisely how a for loop thinks. Now just look at how cleanly that idea translates into code. A for loop has 3 main parts. You've got a starting point, which is int I equals 0. You've got a condition to keep going, I less than 10. And you've got an action to perform after each loop, I++. So as long as our counter I is less than 10, that take step action is just going to keep running. It's absolutely perfect for going through things like lists or arrays where you know exactly how big they are. So for loops are awesome when we know the exact count. But what about when we don't? What if we need to keep doing something not for a set number of times, but until something changes? For that exact scenario, we have the while loop. Its job is incredibly simple. It just checks a condition, and as long as that condition is true, it keeps running the code inside. The very second that condition becomes false, the loop stops cold. A classic example is a video game's pause menu. The game has no idea if you're going to be paused for 2 seconds or for 20 minutes. So it just says, while the game is paused, keep showing that menu. As soon as you hit the resume button and is game paused flips to false, the loop breaks and you're back in the game. The order catch is you have to make sure that condition can eventually change or you'll accidentally create an infinite loop. So when you start to put all these different pieces together, you realize you're not just writing lines of code anymore. You're actually becoming the director of a really complex system of logic. So here it is. This is your core directing toolkit. And knowing which tool to use is the key. Use if-else for any simple two-way fork in the road. When you've got a whole menu of distinct options for one variable, a switch is almost always cleaner. For a sequence that repeats a set number of times, the for loop is your best friend. And when you need to keep doing something until you get a signal to stop, the while loop is the perfect tool for that job. Ultimately, everything we've talked about really just boils down to this one single powerful idea. Control flow is the art of guiding your program. It's how you give it a purpose, a path, and the ability to react to a constantly changing world. So you now have the fundamental map for building intelligent, responsive programs. The only real question left is, where are you going to tell your code to go next? What problems are you going to solve? The journey is completely yours to direct.